And here is our motion in two directions problem, and it's basically a projectile motion problem that I stole from the AP Physics 1 textbook. So let's look at it. It says an owl is carrying a mouse to the chicks in its nest. Its position at that time is 4 meters west and 12 meters above the center of the 30 centimeter diameter nest. The owl is flying east at 3.5 meters per second at an angle 30 degrees below the horizontal when it accidentally drops the mouse. Is the owl lucky enough to have the mouse hit the nest? To answer this question, calculate the horizontal position of the mouse when it has fallen 12 meters. So looking at this, and if you don't know what you're doing, you're gonna be incredibly confused. But when it comes to these sorts of questions, you want to draw a diagram if they don't give you one. So let's just make a very crude diagram over here. So we're going to assume that this is our owl. And then this down here is going to be our nest. And here's the center of the nest. So from here to here, we were told that there is 4 meters. And then this nest has a diameter of 30 centimeters. So it's 0.3 meters. So for all, and then 0.15 meters on both sides. And then we are given that the height over here is 12 meters. And then our owl is flying with a velocity of 3.5 meters per second at 30 degrees from the horizontal. And then from here, it decides to drop the mouse, which makes a motion like that. And we don't know where it ends up, but here's our diagram. So the first thing that you want to do with these kind of questions is to write out everything that they give you. So regarding x, we have that the initial velocity of x is equal to 3.50 times cosine of 330 degrees. And I got 330 degrees from the fact that if it spins that way, you're going to get that. And this part isn't really necessary. You can use 30 degrees, but you have to keep in mind that your y component of the velocity is going to be negative because it's this right here. But if you do this, then we don't have to worry about negatives like that. So it just depends on what you want to do. Anyway, moving on, we know that there is no acceleration in the x direction because where would it even come from, right? And that's going to make our life easier. And the thing we're trying to solve for is x, the horizontal position. And we've already went through this, but you cannot assume that just because this stops, the final velocity is 0. And then we have an entire video explaining why, so just go check that out. And then we have our y component. The y component of velocity is 3.50 sine of 330. And then acceleration is just gravity. It's negative 9.8 meters per second squared. We know that y equals 12 meters, and that's pretty much all they give us. So what do we do with this information? Well, the only component that x and y are going to share is going to be time. So we're going to have to solve for time. And looking at x right now, we only know 2 components. So we're going to have to look at y. And for the y, we know 3 components. And if we use this equation right here, we will be able to figure out the time. So let's plug in our values. Why is my computer overheating? Okay, whatever. And then we're going to solve for t with algebra, which I will skip. But in the end, we get t equals 1.40 seconds. And now, using the same equation, we can get the position of x. So x equals VOX times t plus 1/2 ax t squared. And this just becomes 0 because our acceleration is 0. So in the end, it's going to be 3.50 cosine of 330 degrees times 1.40 seconds, which gets us 4.24. And given that we figured out in our diagram that it has 0.15 meters on both sides, that means that the owl has missed. And you're going to answer no for this question. And there you go. Projectile motion. Pretty simple, right? Just remember to write down everything you know and draw a diagram. And you're going to be set to go.